made, expensive, heavy, and super solid. So what I did on this, in order to demonstrate the axis better, was I put a laser on here, so that wherever that telescope is pointing on this axis, it's rotating straight up and straight down. That's for demonstration on your Alt-S. And then you've got another one here. That one should not move. It should stay right where it is. If this is relatively level, relatively solid, this will almost always go between flat, straight out, right on that wall, right over David's head, and zenith. And that's it. And so it's very, very simple. Two working, and I call them working axis. I don't know what the astronomy community calls them. I call them working axis. They're like the brakes on your car that you use to start, stop, and drive in traffic. They're working. They're service brakes. This is a service axis. So we want to move on to something else. How many axes does an EQ have? Two.
Just one?
Three, yeah. No? Keep going.
One.
Keep going. I'll give you a hint. Jean-Luc Picard was very adamant about this. Four. There are four axes.
Nice.
Four axes. Why are there four axes? What is four axis all about? Because it has an alt. I mean, it's moving through alt, right?
Yeah.
Isn't it? So if I put this right here, look at the light. It's moving through alt. But wait a minute, Brian, that is an EQ mount. You just said it was an EQ mount. Are you lying? No. Well, what about that AZ I promised you? I have an AZ. See the light? It's got an AZ mount as well. So there's an AZ movement and an alt movement. They're not service brakes. They're not the ones that you use to start and stop the car. They're the ones you park the car with. That's your emergency brake. You use those two to set these two, your equatorials. And your equatorials also have a name. What are the name of the equatorial axis? Anybody that hasn't used a telescope before? You've used a telescope before, I know.
Yeah.
The name of those axes are
Great ascension.
declination and your right ascension. Like so. Notice that right ascension was not moving a lot. There would be no parallax error, for instance, if this is perfectly aligned. So it's a little bit more involved to go through and set one of these up. So what you want to do is go, well, here's the deal. I'm here on planet Earth. I'm going to save that laser. Here I stand on planet Earth. We got this node still going. And where we live, we're going to use that as a reference because it's very easy. It's right around 30 degrees. So we're right around 30 degrees. That's our perception of where the North Star is because we're at 30 degrees. Our latitude is at 30 degrees. Equator is up here at the zeroing, and we're coming right on up here. We sit at 30 degrees. So that's why we see this at 30 degrees above horizon. Yeah, there it is right there. Again, no parallax because it's really, really far away. We would never notice a parallax error, whereas if it was in the next neighborhood, we would see that obviously. So being at the position that we're at and looking at that at 30 degrees, right ascension is the one that moves. When you set one of these up and you put your parking brake, okay, we've got this lined up exactly. We've got this lined up exactly, and I'll go through it in a second, what it's supposed to be. And this will probably look better if it's sitting upright. There we go. And you're pointing directly at the North Star. Then when you take this and go, well, let's see, we're going to go over there and we're going to look at that star over there. We go over there and we look at this star and we point at that star. And it looks all kind of like a wonky angle, doesn't it? So now, okay, see the star we're looking at? Now, when we track it across the sky, it follows that arc that represents the equator, because it's on this imaginary axis that points at the North Star. So the item only needs one axis to follow all the way across the sky. You only have to move one axis once you're set up. And that's the beauty of the EQ.
So
And
the
if you're an
tracking,
astrophotographer, that's important.
so question, so the
Okay.
tracking is just the right ascension, right?
That's all you need is
That's all
right
you need.
ascension.
Yeah.
Because the axis, and I have to say relatively speaking, because there is some small amount of wobble, but it's not really a problem during a human lifetime, so we don't worry about it that much. But during the night, we go a certain amount. Quick math. Yes, there's math. Not gonna be a test on this, but there's gonna be some math. How many degrees in a circle? Shout it out. 360 degrees. Okay, great. So that distance is 360 degrees, right? How long does it take the Earth to go around once?
24.
So how many degrees does it move in 1 hour?
15.
15, exactly. So when you're building something, for instance, like an equatorial platform for a Dobsonian and you want to set it on there, you only need it to run for about an hour. So you only need about 15 degrees of movement. I put 18 on one that I built, made it real easy. It goes to the other side, stops, and you stick it back, we'll find your star and you go. So the way we would set this thing up, this is where it gets tricky. This is the reason for your zeros and pre-setting this up before you go to the field the first time with it. Go, okay, I got to do some daylight work. And there's some great videos on doing the daylight work. And that is, how do I know that this is in the right place? Because the objective is to take this imaginary axis, this axis that we go through here, except that this one is just solid. But you see there's a light to that axis, and that axis, that should not move as this thing rotates on that axis. And this will line up the optics going in here. And what you see here should stay dead center of your optics, dead center with the North Star that's up there, regardless of whether you're over there or over there. And that's how you set it. That's a great way to set it up. Get this to the closest, best that you can set it. The closest, yeah, that's pretty close to the North Star. So what we've done is we've cranked this up to the North Star, and we've cranked this left and right, and we've locked it down, kind of loosely gotten it. We know by a compass that that's about the north, and this is about 30 degrees because I've got a gauge on here that says, yeah, I've just set that at right about 30 degrees. Park it, you're done. Set your little clamp on here, and you're golden. Now you want to set this axis. Some of them have a small telescope that you'll look through to pull a cap off, and you'll use that if you're going to do astrophotography, or some way that you can easily line this up. But if you've got your range, your setting circles pretty accurate on here. Sorry about that. I tried to hide, really I did. The objective is to have an imaginary line, that imaginary laser line going through here perfectly aligned. The way you get that, set this here, mark it right down, is you would line up your zero line. You've got a little marker. Most scopes have some kind of a marker on here that you can take out during the daylight, get it roughly where you need it to go, and then you go and you find something that's not going to move, like that telephone pole that's 4 neighbors away. That's pretty good. Some top of a hill that's far out there. If it's in the evening and you really want to do that, there's those things with the red lights that blink. They're one kind of a cell tower or another. I use those for collimation all the time. But what we want to do is we want to line this up in such a way, because this always moves. When you're in this app, you have to store this in a different location to track it out there and pack it in the back of your car and everything. So you want to set it at the 0. Did I get that accurate? And what about this part here? Is this accurate? Because there's not an adjustment for that. You'll shim that sometimes. You'll loosen this up. That wasn't me. And you'll put it over here and you'll look at what you see in your telescope when what you see in here is lined up on that static whatever. We'll just call it the telephone pole. The telephone pole is static in here, we're pretty sure. And then you go 90 degrees and look at where the telephone pole is, line it up in here. Let's go back and forth. And then you take it and do this with it. Flip it over in the other direction and see if it moves to one side or the other. Okay, if it moves up or down, you're off this way. So your 0 is not quite right. You're close maybe, but not quite right. If it moved left or right, then you're off. You go back and forth. Your telescope is off this way. And that needs shimming. I wouldn't shim between the telescope and here. I would take my paper or my cereal box or whatever I'm going to use. Maybe you have a really nice telescope with something built in. There is a shim on the back of this telescope right there where I was setting this up. You can't see it, but because we don't have too much more time, you can see it right back here. I put a shim right in the back of that between that spacer and this, because that telescope needed a shade bit more this way, so that when it went from one side to the other, that object is still in the center. The more it moves off center, the more you need to shim it. Put a piece of shim. Oh, it's farther. Okay, then you got to go the other way. Loosen up a screw and just tuck that paper or two pieces of paper or one piece of cereal box and put it on the telescope, and then it's always
Hey, you
lined
might
up.
want to be careful of that laser.
Sorry. Here we go. Did it get you?
Not that I'm
I
around.
missed. Okay, I'll try to work on my answer.
Who asked me that?
Anyway, laser's off, but that's how you would set this up to get it pretty accurate in between here and here, and go ahead and line up your setting circle with a clamp on your zero as close as you can get it, so that when you go out and you go to do that alignment, okay, we waited until it's dark, we've come straight up and down. Sometimes you can get that visually, but there's also a zero here. I use the zero that's on here. I set all of it up during the day. So I just go 0 and 0 to get them really close. And then after dark, to get it the most accurate way, whatever sight I'm going to use, well, I can use this as my sight. I can look directly through my telescope. If it's lined up, I know I've done it lined up mechanically with this axis. Then I can go find the North Star and look at it this way, and you make your adjustments down here on the park and brake, the Alt-Az at the bottom, because there are 4 axes. You just don't use all of them all night long. You got one of those with one of these on top of it. And that's all it's doing, is it's parking this where you need it and locking it down left and right until that object is dead center. And then when you go and find your object and you start tracking it slowly at sidereal speed, it shouldn't drift much at all. And you only have to use one axis. That's the good part of having an EQ. It is more difficult to set up if you just go, I just want to go play with the stars and look for a while. This is your friend.
One
Time we
last thing with a manual EQ, once you find an object, if it drifts, you only have to adjust one. to
Correct.
find it again.
You're only tracking it with one. And invariably, the most basic models, especially some of the lightweight and older models, only have that one flex attorney.
Yeah. The
Okay,
slow
that the
motion
one flex attorney is, he just kind of induces less vibration because you're not touching the telescope much. And that's all you do is go tweak that a little, but you don't have to follow 2 axes. On that, I have to follow 2 axes no matter what. And a computer has to drive 2 axes and work an algorithm that is functionally kind of like a sinusoidal wave. And of course, the object does this. So it's not that great for astrophotography. Even solar photography, if you're going to do anything long, you need to set up on an EQ, but a couple of quick images for solar photography, because you got more light, your exposures are much shorter. But yes, that's what it is.
You
It
probably
brings
do
it
like
down
a-
to only one
You probably do a
axis.
decent image of the moon on an Alt-Az.
It's
right?
bright enough,
Bright.
absolutely. Alt-Az you can. Anything that you're going to do a 15 seconds or less, you'll never see it or
Or if
notice.
you're doing like a wide field with a short refractor, you can probably do on an Alt-Az.
Absolutely. Or you could do some kind of a multiple of the thing where it goes part way and you re-expose, part way, re-expose and keep it static. You know, there's a lot of creative things. I don't do the astrophotography side of it. I work on the mechanical side of it, and I spend a lot of time learning how do I line this up. And for me, it just seems like there should be a hard stop that you could put over here. I haven't built one for this. I am building it into another telescope that I'm working on. You'll set an adjustable hard stop. And when you flip that hard stop down into place, you can bring this right up here until it goes tink, and it hits it. And then you lock it and you flip that hard stop out of the way. So it's a real quick and easy way to go, okay, I want to go back to and set up right here. Now I know everything is lined up accurately, and it's all about this axis, because the other one's not really that crucial. You can set this setting circle anywhere that you want. It's, as long as it's back and forth and aligned with that axis, because quite literally, the world revolves around that axis. And so you're just gonna go over and you're gonna watch that arc as it goes across the sky. And that is where almost everything is, with a very few variations. The moon travels at a different speed, planets travel at a different speed. And it is noticeable in one night's time.
The North Star is close enough to visual, but like
Close enough.
astrophotography,
Astrophotography, you got that little
it's
chart.
not exactly dead over the pole.
Mhm.
So
So most of the time, there's a little circular chart, and you got the year and the date and several things to tell where the wobble is. If you've got to have that level
yeah,
of
I know
precision.
my Celestron scopes have they have a method where you get it roughly lined.
Mhm.
And then there's a method where you go in and it will go point to a particular star
Mhm.
and it will center it where it should be if you're polar aligned. And then you use those two axes.
Use them as a
and
reference.
You center it on that.
Exactly. You're using
Then-
the all
then it does
DAS.
get perfectly-
And once it's set with the all DAS, if you get that lined up well enough, the idea being the North Star is the reference,
Right.
but it's actually the rotation of the planet that you want to line this up with as much as possible. So I know this doesn't look as much like a lot of the pure EQs, because this is a hybrid. It does EQ and AZ, and I can convert it right here and reboot the software, and it switches axis and it'll sit flat and you put another telescope over here. There aren't that many hybrids of these out there. They're not that popular. But if you get one that's a large, heavy, like the one this gentleman's body was showing me, they usually come down here, they're more of a taper at the bottom, and that's where the weight feeds out, because they're really designed to operate as an EQ, but they still have AZ on the bottom. And so that's their setting. And got any other questions on this, and what time do we have?
When you can also get a wedge.
I got 5 minutes.
You
A
get
wedge is-
for an
A wedge is, yeah, if you've got an AZ and you want to convert it to the wedge, but you'll notice you have to upload the firmware.
Right.
You're doing that, and it switches what was the we call it alt as, it's the azimuth mount.
Right.
It switches that, now that is now your right ascension.
Right.
And you're tilting that up, in our case, about 30 degrees off. Okay, what time was it again?
You got 5 minutes.
5 minutes, okay. Any other questions on that or anything else you want to see? I can do a quick read off of some of the other subjects as I went through and refine them for future things. I was thinking we'd do some basic stuff, kind of go through the basics that people want. We got some positive nods in response when I was doing my survey on this. And so it seemed like a good idea to write a bunch of those down. So in astronomy, practical astronomy, tonight was, and we can do these again, the difference between mount types, why an AZ alt as is easier to start with. Another one that I did was, how much did I magnify that? Everything you never wanted to know about eyepieces. We can talk eyepieces. They are cool. And it's more than just that there's big ones and small ones and expensive ones. What they do is, that's worth the practical astronomy. Anybody interested in that at some point? These aren't in any particular order. Solar observing setups and mods. What won't burn your eyes out? Because someone's going to come up to you and go, why are you doing that? Aren't you going to burn your eyes out? Yes, that's why I'm here.
Some beautiful views this weekend.
Some amazing views, and we've got a very active and exciting sun, and there's more stuff coming around the horizon.
Yeah, there was a nice big sunspot. this
Yeah,
weekend.
yeah. that
A
was
big one, and there's a new one that's just come around, and it's like a little double, so it might fling some stuff at us.
Awesome.
How to use a planisphere. The best planisphere is 3 miles away. I should have put from my house, because that's where Mike Krashansky lives. He published what I think is the best planisphere ever made. How to collimate a Dobsonian. It's like a piano. Move it, tune it. Got a couple of different things that are really useful. I prefer the laser method, but we can go through different things. I can bring a small Dob in here and we go through collimation. You can collimate anything. Anything can get knocked off. This can go off collimation, but it's built like a tank. Unless you really mess up, you're probably not never have to collimate your refractors, your typical refractors. Sometimes you do. Catadioptrics, Schmidt castes, and what have you. Yeah, they can be taken off. And it usually involves 2 guys and some beer to align and properly collimate. I've done it several times.
You pour
Who
the
was
beer
it?
on it, is that how it works?
No, I pour the beer on me
Oh.
because it's so hot out there.
Can I buy you a beer?
Bino viewers and their use. Pirates don't use eye patches these days. There's an explanation for that. Finally got some experience with that. Absolutely adore bino viewers and finding ways to use them in just about every kind of telescope. There's a time and a place, and they are neat. They're really cool. Weather conditions, put the cell phone down. What am I talking about? Guess you're gonna have to show up to find out.
Nice.
Any other questions? Anything while I'm at least pulling this guy down, and then we can go on and proceed with the meeting?
Maybe another topic would be, different optical designs and advantages and disadvantages of each.
If you want to go through that one, we'll put that one down. I will go ahead and write that one down. Optical designs
Like
and
refractor, Newtonian.
Exactly.
X-ray,
the explanations of reasons of
how
how's
they
and why.
work and
Okay.
What the pros and cons of each type are.
Filters.
Filters, you want to talk filters?
Yeah.
Okay, I'll put down for designs and one for filters. I don't know all the stuff about filters, but I've got enough little ones that I fill in for this job or that
Are the
job.
color filters even worth it?
That probably is a good title for it. Are the color filters even worth it?
Light pollution filters for the city.
Bill's got something to say behind you.
Is he behind me?
Yes.
By the way, some of the big sunspots are visible naked eye now. Absolutely. Yes, sir, they are. And they are more of them coming around the proverbial bend, so we're getting more.
But naked eye was something over
So
your
do
eyes.
do we know
Yeah,
what is
with
the
solar
rotational period of the
glasses, I
sun?
heard you can see under
Do we
the
know?
solar.
It's about 25 days at the equator.
Yeah.
Give or take. So something will typically go across the sun from a decent-ish view to a decent-ish view in about 10 days. And then it'll change. It may even fade out. So a lot of times what happened around the backside of the sun formed while it was on the backside of the sun, or it's that next named one coming around. It's sunspot 26A, what have you. Any
Brian,
other-
I'm not an equipment person at all, but I wonder if in some of these that you're doing, people are always asking about how to clean mirrors.
Yeah.
Well, I just put that on Facebook. How much do you like Guinness, everybody? 'Cause it took me 3 Guinness and 5 gallons of distilled water
Wow.
and patience and the removal of this ring.
How big was that?
And I have a very clean 18-inch telescope, but I'm really happy with the mirror. I thought it would be damaged. It is so clean.
I cleaned my 6-inch in about 15 minutes.
We could talk about that one. That's one I prefer to have Grego on, because one thing about it is he brought up all the discussions about grinding your own mirrors. So we could do a section or a series just on mirrors. But for practical astronomy, the last question I want to leave you with is, since these are not in order, and we want to try to do 25, 30 minutes worth of practical astronomy.
This thing is unmuted.
I just want to do it. We've got our basic stuff, stuff that'll get you on the field that is, as the name implies, practical astronomy. And every so often, I'd like to throw in something that's really advanced AT. It doesn't have to be the whole project. It can
Did you
be
see that?
just working on that part of how I built the focuser. How do you build a mirror? What technique do you use for this or that? We can do a
Now the speaker is muted.
But Brian, I have a question. Steve Barrett. What about some amateur spectroscopy? Can't hear you.
I think Brian got muted again.
Okay,
That's a-
that's
That
one way to
might
make filters.
require more than a half an hour, but we can figure that out. at the
But
time.
for the sake of a practical astronomy, that was my vision for it. Now that we're all starting to meet together, and if everyone's in agreement and you like it,
Mhm.
then okay. What do you say? That's it? Any other questions?
Say,
Well, I
Brian,
wanna
could
say
you,
thanks to Brian.
if you could add spectroscopy to it,
You started
appreciate
the
it.
practical astronomy session, I don't know how many years ago, 8, 10 years ago. My sense of time is messed up by the fact that we kind of lost a couple of years. In there. But I was looking through some old newsletters yesterday trying to find something. And there were an awful lot of sessions where it said, meetings where it said, no practical astronomy, no practical astronomy, no practical astronomy. Well, I think Brian's gonna take care of that. And I think that's great. And I'm sure he's got a long list, obviously, but if there are other people who have ideas or want to help. he
Absolutely.
would-
Text, email, throw me the idea for something you want to do. Practical astronomy is about the hands-on practicality, and I tend to go, give me something we can use at the field.
Yeah.
Something that I can show you, and if you need a repeat on something, just let me know. We'll do a repeat. There's probably better ways to explain it.
So this is my first meeting. There's another talk in a couple minutes.
Right.
Yes.
Is there usually time after the chit chat with members of the club? And stuff like
Yeah,
that?
and we usually go to, we've been going lately over to the Crown and Anchor, which is over on San Jacinto, for food and drink. and that's another opportunity too. But yeah, there's usually people are kind of hanging around after the meeting, so. Yeah.
I'm just gonna pack down this optic. Y'all go ahead and proceed
Okay,
accordingly.
that's fine. Thank you, Brian. I'm gonna turn on this. I hope I don't screw everything up, but I'm on the doc cam for a minute, just to have an agenda. Here we go. All right, we need to zoom it out. I don't want to zoom out any more than that, but that's okay. All right, we will now actually move to the General Assembly meeting. My name is Joyce Lynch. I'm the president for any of you who haven't met in the past. What we like to start out with is introductions. Anybody, we've already heard from one person who's new, but you can tell us more about yourself, and anybody who's just a new member or a visitor, just give us a little introduction so we kind of know who's here. You can start. You already started. You could say some more.
All right. My name is Josh. I just moved here from LSU. Just graduated. Got a job over here. Thank you. I have a background in physics, and I've been doing astronomy for, well, astrophotography specifically for roughly about 10 years. And after moving here, I've been re-interested in visual astronomy. So I was looking for a club around here to meet people who, do similar stuff. So,
I think you found the right place. Anybody else in the room? Yes.
My name is William. I'm a student here at UT. I'm working here over the summer. I got into astronomy really recently because while I was in China over the summer, I actually saw the ISS overhead time.
Oh, okay.
Okay, great. Anybody else? Anybody on Zoom who wants to introduce themselves? Oh, sorry. We still have one more person in the room.
So I'm request to my name. So my name is Zheng, Z-H-E-N-G, and I had a PhD in plasma physics.
Okay.
So it's the space plasma physics. But I'm currently working for a bank, and I science. So since when I was in high school, I really loved watching the sky. No, I should say since when I was a kid. And but I don't have telescope. I didn't do any photography but I'm still very interested in the space astronomy, the space travel thing.
Right. Thank you. Welcome. Anybody else in the room? Anybody on Zoom who wants to introduce themselves? We can hear them. I'm not sure. Anybody?
Should be able to.
Okay, I guess that's it then. All right, let's on the agenda, the minutes and the treasurer's report, rather than going through them in the meeting, we just started saying they're in the newsletter. You can look at them. If you have any questions, ask the treasurer, or any corrections of the meetings, email the secretary. Officer reports, Terry, communications.
Well, we're still trying to get some traction on two big projects for basically the website. We are working on there are a couple levels there. At the bottom level, we're looking at replacing our web hosting from Midface, which we're using right now, to AWS, which is Amazon cloud-based. And then at the same time, we'll do that first, and then we'll turn our attention to replacing our member management software, which is currently Wild Apricot. And there are a couple of candidates still out there, but there are a couple of good ones that are low cost compared to Wild Apricot, which I think on the next go around, they're going to want about $2,700 a year for that. We can get these others for about $45 a month, which
$45.
Yeah.
And Wild Apricot does a whole lot more than what we need, I think, which is part of the discrepancy as far as the cost is concerned.
Charles was asking me from the treasurer's perspective about timing. He's putting the budget together, so I'll get with him this week and we'll talk about what the costs are going to look like based upon when we think we can make the transitions. But I think the wild apricot is already paid through the rest of this year. I don't think they give any proration on any for that. Midface itself, AWS for better performance, and the cost is reasonable as well. Let's see. About the regular volume of traffic, we're still getting a lot of queries in about the eclipse and in general from people outside of Austin and AAS who are asking how they can handle things, what they can do here about visiting Central Texas. And we are currently are directing them to some established sites like the Hill Country Alliance and others, Texas state park sites and things that can help them figure out what they might have available. That's about it.
Jamie, I skipped over you. Sorry. Vice President.
My feelings are hurting my head. I'm coming up here just because I want to my sketchbook.
Okay.
Not that I like being up front and center. But
Do you want to
anyway.
put it, if you want to put anything on here, we
Yeah,
can
yeah.
take that off.
Well, first off, yeah, hey guys, as Vice President, my main task really is just wrangling speakers and venues for us to meet, including working on possibilities for our Christmas party in December. But in the meantime, there's the big issue of where we want to continue to have our GA meetings, our monthly meetings. And of course, we've been meeting here for many years, but ACC has, well, we've been working with the professor over at ACC who has offered the Highland Mall campus location as an alternative. And there are pros and cons for each. Highland Mall has free parking and closed parking. And I think that's one of the main, and the traffic's less getting there. But they also close promptly at 9 p.m., the buildings. So we have to be out of there. And here, we can lollygag as late as we want, pretty much. So we have to have meetings there from 7 to 9 instead of 7:30 time. But also, we've been having some difficulty getting the rooms reserved at ACC. And the last time we were there in May, had to flag down a security guard to let us in the room. That had the happy consequence of us not getting charged. We never still, no bill, okay, awesome.
Whether or not we do.
But we do normally have to pay $65 a month to ACC for when we, $65 for that room reservation that evening. And here, there's no charge. And the classrooms we've been using there have been, or I think we just have been in the same one, but it is a good deal smaller than this one. It still holds about 35 people. And I think that's probably sufficient. So anyway, we've been here at UT this summer because the parking has been better, the traffic's been better, but classes start at the end of August. We'll be back here next month. And then at the end of August, classes start. And so we're looking to go back to ACC for September. And we've sent out emails and requests for, folks with opinions. So haven't got a whole lot of feedback. That's cool. We made the executive decision to meet here this summer. But, any thoughts, suggestions, ideas are always welcome. And then next month, oh my God, where are you? Next month, actually for August, I don't have anybody solid reserved, several people on the back burner. And for September, possibly, Dr. Chatterjee. So anyway, several people in the lineup who are interested in speaking to us, who are available, and that'll settle out, as we get closer. Trying not to do last minute. So that's pretty much it with that. And I just wanted to real quick, I'm a traditional artist, so I work with pencil and paint and stuff like that. And even though I'm, a computer science kind of geek and student finishing up a degree, I don't have a lot of familiarity with design software. So I just draw pictures, and I just wanted to put these up as ideas, some other ideas, just working on the logo. The logo's great, but I've been wanting to just add something to it that says Texas, that says Austin. Those are a couple ideas. And then I got a lot of sketches here, but I wanted to show you this one. This one with the capital in behind, and it's still playing off that same design of our logo, but just adding some more elements. So anyway, just throwing it out there. Input, suggestions, always welcome.
vicepresident@austinastro.org.
Oh yeah, am I supposed to answer that email? I forgot there's an email. Anyway, thanks guys.
Okay, any questions for Jane? Let's see, equipment, Greg Rhodey is our equipment chair. He is not here. He is out in Oregon at some, I'm sorry.
He's on Zoom right now.
Oh, you're on Zoom. Okay.
Yep.
List. You have anything to tell us, Greg? How's Oregon?
No, not really a whole. Let's see. We finished up the cleanup at Kim Warren's place. That was about it. That's about it.
Well, I hope you're having a good time out there. Is it cooler there than it is here?
It certainly cools down at night. Yes.
Doesn't cool down at night here, unfortunately.
Daytimes are in the 90s here.
Okay, well, it's 107 today here, so that's better.
Okay, so hasn't really peaked in yet, huh?
Right, I'm afraid. Jefferson.
Greg, when are we or what's it gonna take to get the mirror into the spica eyes?
2 people.
And how many beers?
And how much Guinness? Yeah, okay.
Okay, well, you'll be back, what, the 6th of August, did you say?
Yeah, something like that. Actually, there is one item that I need to talk to the EC about before I come back, because there is an opportunity here that I want to talk to the EC about first.
Okay.
There's some equipment available here.
Okay, well, email us or email me or whatever.
Okay.
Okay.
Yeah. So I'll be out of touch for the next week, and then I'll be available for 2 weeks after that here in town. Basically, what it is all of the mirror grinding and polishing equipment from Obsidian Optics after he passed away last year. That's all being held by a friend of mine here in Portland, and if we want it, we can get it.
Okay, all right. We will discuss that.
Okay.
Thanks.
Mm-hmm.
All right, member services. Brooke is our chair. She's not here, but I know that tomorrow evening there is a member star party at Pedernales Falls State Park, and so if anybody who is interested, the office is going to close at 7 o'clock. So just you drive on in and take lots of water because it's going to be hot. So anyway, we get to go to Pedernales Falls 4 times a year for our member star parties. Other than that, they're at our Bad Wolf Ranch, our dark sky site. So
is anybody hosting that?
yeah, Ramon Salvania is going to be the host for that. He's been briefed on what he needs to do. And so don't know how many people, I don't know if we've heard from anybody. We didn't really ask, but that's what's going on tomorrow night. All right, outreach, Ed LaBelle, our outreach chair, is in Florida at the moment. Apparently it's not much more comfortable there than here. They have more humidity. The temperatures are lower, the humidity is higher. But there, we had a member or a public start party at Pedernales Falls last Saturday that went really well. The sky was fantastic. We had about 130 people and there were probably 12 to 15 scopes. We've got, yeah.
So you added up that list of all the visitors?
Oh, yeah.
So 130.
About 130, yeah. Yeah, we tried to keep good track of how many people came in because the park interpreter had asked us to, and that's what we got. So the other outreach event that's happening is August the 5th, which is Austin Under the Stars. This is an event we have done many times over the years. This is the first time we've done it since 2019. We're out at St. Stephen's Episcopal School off Loop 360 near the Pennybacker Bridge. We'll want members to come out with telescopes, binoculars. We'll also need people to help with some kids activities and the welcome table. So Ed will be sending out information requests for volunteers for that. And the other thing is, if you look in the newsletter that came out today, there is a flyer for Austin Under the Stars. And one of the best ways to publicize it, we think, is for members to make a copy of that and put it at your kids' daycare center, at your work, at the library, wherever. So, page. I'm sorry? On your Facebook. Yeah, we're going to get it on Facebook, right? But anyway, that's a way that we can really spread the publicity around. So look in the newsletter and find that and make a copy and put it up.
So Joyce, since I didn't have Austin Under the Stars for a while, what is the age limit for kids that's, kind of like, what time does it start and what time does it end?
It starts at 6, it ends at 11:30, although I will tell you, usually people stick around after the official end of the event. I don't know, I think that generally we've had kids of all ages. And to some extent, I think it kind of appeals to elementary school, maybe middle school, but it's really for anybody who wants to come and look through telescopes. And we are going to have some kids activities. Unfortunately, this year we cannot have the mobile planetarium. We've usually had that, but due to staffing issues with Stars and Science Austin, who are the ones who do the mobile planetarium, we're not going to be able to have it this year. So, but we'll have other things. My husband is going to help the kids make rockets and launch them. That's always a lot of fun. So, yeah.
What kind of rocket?
Jim, talk about the rockets that you make, please.
Okay. The rocket's fairly simple. You take some PVC pipe, you wrap a couple of sheets of paper around it, take that together, take those cone-shaped cups that you see that fit on the side of the cooler. One of them becomes the nose cone, another one becomes the tail cone, the drag cone on the tail. Duct tape the whole thing together, slide it off that PVC pipe, and then my launcher is some 3-inch PVC pipe that I pressurized to 30 PSI. Then 1-inch PVC coming off of that with a sprinkler valve, which will work on 18 volts. So 2 9-volt batteries in a launcher, press the button, and it launches the rocket.
So no flames involved?
No flames involved. It's too hot for flames.
Well, and I was asked too about, did we need a bunch of the soda, 2-liter soda bottles? Because that's another way to do the rockets. And Chris Bernhardt has done that at Star Parties, but we're not doing it that way. We're doing it with the paper, which I don't know, maybe that's a little bit more environmentally friendly.
Or safer.
Yeah, the 2-liter bottle are what are called stomp rockets.
Yeah.
Where you have some pipe coming off the 2-liter bottle and you stomp on the 2-liter bottle as your source of compressed air. But we have access to power and I have a compressor, so pumping air into the 3-inch pipe is easy enough.
For those of you who have been at Austin Under the Stars before, I will tell you that we are not on the same field as we have been. We're not on the soccer field because they're in the process of putting artificial turf or putting natural or something. I can't remember, but anyway, they're working on that field. But the football field is right next to it, and that's where we're going to be. And it should be just as close. It's just as close to the parking and the buildings with the restrooms and all that. But that's where we're going to be instead of the usual place.
And starting at 6, I'm assuming.
Does it start early enough to observe the sun before it gets dark?
Yes, that's the idea. And Brian has brought the 2 solar scopes from Pedernales Falls.
Actually,
Anybody else who's going to be out there and wants to do solar viewing with filters or funnels or whatever, yeah, we will be looking at the sun, which should be probably will continue to be pretty impressive at that point. So, yeah.
This is Steve, I'll bring my solar scope out.
Great, yeah. Okay, anything else? Any other questions? Yes,
How many volunteers will be needed?
as many as we can get. You know, we do not have an upper limit. It's out there for anybody who wants to come. And as I said, if you got a scope that you want to bring, fine, but if not, there are other things that we can find for you to do, and just to talk to the guests and work with the kids. Jim can always use help with the rockets. So never an upper limit on volunteers.
There's really only one qualification. You hold the mirror up, right? And it clogs up.
Right.
Qualified.
That's right. That's right. And I don't know if there are people that aren't as experienced as some others. You come and you learn. That's a part of it. We're not expecting everybody who comes out to be an expert on everything astronomical. You come out and you circulate and learn from the people who are a little bit more experienced than you are. Alan?
Yeah, I would recommend everybody get out there if you can, because it's a lot of fun. You meet a lot of people. A lot of kids go out there for outreach. It's great to be able to show them the stars through the telescopes. So it's a great time for everybody. So try to make it out there.
Right. Okay, so that's 3 weeks from tomorrow, the 5th of August.
And, Joyce was saying that I could use help with the rockets. I know several years ago, Dawn's son helped me a lot.
Nice.
And he was about 7 or 8, but to him, this was a totally great way to spend the early part of the evening, was teaching other kids how to build rockets and then launching them for them.
Mm-hmm. Okay, any of the members at large have anything they want to report?
Do you mind asking for a show of hands who might come to the member star party tomorrow night?
Okay, anybody here coming to the member star party? Okay, a few people.
Cool.
Yeah, okay,
Fun.
all right.
All right, thanks.
Okay, newsletter, anything you want to say, Nathan?
No.
Came out today, so,
I got it out.
okay,
Yeah.
great. Yeah, yes. Is Jake on, Terry?
Don't think so.
Okay, no, so nothing from the webmaster. Is Ernie Leaf on?
Don't think so either.
Okay, nothing from, okay.
You want to plug Discord, Joyce?
That's a good thought, yes.
People use it.
Let
We
me
did get the invite in the newsletter, so I'm happy about that.
let me ask Dawn to do an Alcor report, and then we'll talk about Discord.
So I'd say the most exciting thing on the Alcor front is, after many, many, many years and much frustration, the Astronomical League has a new website design. We don't know if it's quite functional, but it looks like it's on its way. It's pretty. It is pretty. What's
More
that?
up to date than it's been.
Exactly. You log on and it's no longer here are the Astro Sketch winners from 2018. So Alcon is still taking place in New Orleans later this month from the 26th and the 29th.
Baton Rouge, isn't it?
In Baton Rouge, yes.
Yeah.
Astronomical Gumbo. They still have rooms available. In fact, they've extended the room block to the 20th. So if you want to plan this last minute, there's still availability. Some of you may have seen that I sent out a request for astronomers who want to enjoy the stars, the Perseids, some good wine. And so that's, again, we're doing, I think this is our third star party with Stone Ledge Winery and the Lampasas County Friends of the Night Sky. And that's on August 12th. And I know you two are planning on coming.
Oh,
I'll be there.
Which is actually the date of a public star party at Pedernales also, but Pedernales is south.
Yeah.
That's north.
It's
so
the
you
night
have
of
a choice.
many, many star parties because we don't have a moon this year.
Yeah.
Also, I said I would give a plug for U Bar U Star Party that's happening outside of Kerrville at the middle of August, the 17th through the 20th. They do still have some bunks and some camping available. And there's also still time to get in on their annular eclipse event on the 14th of October. Also have recently been inducted into both the NASA Partner Eclipse Ambassador Program and the Solar Eclipse Activities for Libraries Eclipse Experts, or SEAL. We still need more people. So if you guys are interested in taking part in either of those programs, the only restriction is for the Solar Eclipse NASA partners, you cannot also be a NASA solar system ambassador. So you have to pick and choose your battles. Other than that, just a quick plug, I got to attend a workshop last month to develop these light sound devices for individuals who are hearing impaired for visually impaired to experience the eclipse. And I'm hoping in the next month or so to start putting together logistics for a workshop for AAS to build these devices. So if this is something you're interested in, you do not have to have soldering or equipment experience. It's actually very user-friendly to put together. So reach out to me and we'll get you all gathered together. And hopefully, how does it work? Oh, well, unfortunately, we don't have a sun in here, but it has the ability to receive light on this back panel. You can either have it connected to headphones like these are, or to a series of hubs that other individuals can connect their cell phone or their headphones into. And it reads the light brightness and gives you an audible pitch. I think it starts at flute and it works its way up to clarinet. And there's a lot of different programming features that can be integrated into this. We're actually going to be looking at partnering with the Austin Public Library downtown to utilize their 3D printing lab to help make the cases in exchange for having ideally at least half a dozen of these available at the library system for folks to check out, not just for these upcoming eclipses, but any future eclipses.
Nice. Okay. Thank you, Dawn. Other question?
Yes. Oh my God, yes, yes, please.
What's that?
Yes, if you could send me one of his visually impaired students.
Ah, oh, okay, great. Great. Connections. Okay, Charles mentioned Discord, which is our, I don't know, what do you call our program, our app for chatting with each other and posting things about astronomy and so forth. And we're really trying to promote that. And we have had Signal for a while. And that's the usage of that has really gone down a lot. And so we are going to kind of start de-emphasizing Signal and instead emphasize Discord for chatting and posting information and so forth. So if you haven't already checked it out, there is something in the newsletter that tells you how to get onto Discord, and there is a video that in January of this year, Jake Knobloch, who's our webmaster, made a presentation at a meeting, talked about how to work with Discord, how to get on and post and all that sort of stuff. So that's included in the newsletter article. So we're going to try to emphasize Discord and see if we can't do a little bit more in the way of communicating. Those of you who've been around for a while, years ago, we had a Yahoo group, and that was the way that we sent emails around and communicated, and Yahoo quit. Well, that kind of really, the use of that really decreased over time, and then Yahoo quit supporting that. So Discord is the new thing, and check it out if you haven't already, and use it. Okay. All right, the next thing is I just want to talk a little bit about the eclipse location application. The email went out yesterday, which kind of explained where we are on allocating spots at Pedernales Falls State Park and Bad Wolf Ranch for the total solar eclipse next April. And there's a form that anybody who is interested in being considered for one of the spaces that will be available at either of those two locations, filling it out, giving us some information, and then we will look at the response that we get, and we're asking that everybody respond by the end of next week. We will look at that and start figuring out who we have space for at the locations. And as Terry said, we've been getting a lot of emails from people all over the country, really saying, can I join your club so I can be at your event? Well, probably not, because we think that the number of spaces we're going to have at these two locations is probably, there are probably going to be taken up by people who have been members for a while, and we're not going to leave them out for the sake of somebody who's brand new. I mean, I appreciate people who are interested in the eclipse and want to send us their money, but the fact is,
How much money?
right? Yeah, that could be a consideration. So, but so basically, we're doing this 9 months in advance so we can see our current members and what their interests are. And it's interesting. We did a survey a few months ago in which about half of the people who answered said they had other plans. They're going someplace else. So we're hoping that we're all of the current members who are interested in being at either of those two places, that we're going to have space for them. But we'll see what the response from the form, people filling out the form is, and go from there. This afternoon when I checked, we had 23 responses already in less than 24 hours. We'll see how that goes as more people read the email and do it. But this is what the EC's decided, trying to be fair to allocate these spaces for people. At this point, we have not heard anything from Inks Lake State Park about their need for volunteers. So we're not really counting that. I know I have been in contact with people from the city of Austin and Travis County, and they may be wanting some people for their parks. If somebody wants to do that and get to a pretty good spot without going too far, that's another possibility also. So obviously this is all a work in progress, but if you haven't looked at the survey and the form, the email with the link to the form, and you're interested, then do that and get your name on the list, and we'll see what we can work out. Any questions from that?
Joyce, I may have missed this, but what are the corresponding plans for the annual?
There are not, and that was actually a question that came in because the email that was sent said, if you have any questions, to email me. At this point, we don't, and that's partly or largely because of the fact that we're not getting an annular here in Austin. It's not annular at either Pedernales Falls or Bad Wolf. It's partial. In Austin, we have 89% coverage. There may be, I'm working with a group of people here in Austin, and we may have some events somewhere here in the city. But on the other hand, as I told somebody who had emailed me, you kind of just need to go out in your yard or a parking lot or a park or something to see if you're happy enough with the partial. You don't necessarily have to go somewhere. If you want the annular, you have to go south or west. But Dawn?
I was gonna say, if there's anyone that wants to experience annularity while also doing outreach, the STEM Eclipse group out of San Antonio, which is a conglomeration of a lot of the museums, their school districts and educators, will eventually be putting out requests for volunteers. So that will be an option.
That'd be some good to put in the newsletter.
Where are they going to observe?
Various different locations throughout the city.
They got great museums.
Yeah.
Mm-hmm.
So I noticed, I know that there was on one of the Hill Country Alliance Eclipse roundtables that Dawn organizes, there was there, and there was somebody from, I think maybe from S&T, I can't remember, who said that an annular is like, the interest level is like 10% of a total eclipse.
They're really cool if they happen close to sunset or sunrise.
Mhm.
Other than that, it's nah.
I mean, if you want the best possible experience, I would say get to Bandera because they're intending to try to break a Guinness World Record by having the most people gathering during an annular eclipse singing Ring of Fire.
Cool. You have a chance to make history. Yeah, yeah.
I would also recommend, I would also state that if you get to see it, you'll be extremely happy that you went through the effort to see it. It's not a total, but it's pretty extraordinary.
Yeah, and probably, I don't know, well, the last one for a while, I guess, because we keep hearing that these are the last ones for North America till the mid 2040s, I think. Yeah. All right, does anybody have anything else that they want to ask or comment or anything? All right, Jamie, I will let you take over and introduce our speaker.
Bruce, can you put the,
Yeah. Put it back to.
no, take that down.
Yeah, right. Put it back to display.
Yeah.
HDMI.
I do want to say before I introduce our speaker that you guys, a lot of you probably already know this, but many years ago I read Isaac Asimov talking about how if the sun was a different shape, not circular, that the dapples that we see, they call them dapples, we see on the ground underneath the trees, would not be little, round dots. And it never occurred to me that the leaves create pinhole cameras, and so these dots are miniature, they're pictures of the sun that you see all over the ground. So check it out when we get this annular eclipse, or even if you see a crescent, make sure to look down because you'll see all those little dapples in crescent shapes or rings. And it's a kid. He was saying like if the sun was triangular shaped, you'd see the triangle.
When we were at the 2017 eclipse, it had been raining, there was a puddle. The eclipse was reflected in the puddle, which was then reflected up on the underside of the shelter we were on. That's really cool. So that was wonderful about that. Thank you, David.
Fun with the sun. Yeah, thanks. Anyway, so our speaker tonight is Bill Ambrose, and I met him for the first time. He's spoken to the club a few times in the past, but I met him about 3 years ago. It was pre-pandemic or just before the pandemic hit. And he's had wonderful talk about some of the most dangerous places in our solar system, like the surface of Venus and Io and volcanoes and fun things.
Awesome.
Yeah. And I got an invite afterwards to go see core samples up at the Bureau of Economic Geology, which is where he works. And then everything closed down. So now I'm trying to take him up on the offer again. Meanwhile, he's going to talk about lunar ice, and I am honored to.
Okay. Everybody hear me? Yeah. Yeah. Okay. Just an invitation. Back from the a few years ago. The first one I always could happen. Certainly the Artemis program, which is going to go back to as very good. It's not just the US, also the greatest money with the August, they will do actually not. They're not doing it's Counting since the mid-70s. Even before when kinetic friction and that in the sample, back in 1976, and they really are in 2022, and they're lucky to get that. So, okay.
Excuse me, the audio is very choppy.
Yeah.
So I should mute mine?
Mute yours
That's probably
and
gonna join.
see how it works.
Okay, how about now? Sound better? Guess I should say something.
Much better.
Okay, yeah.
Okay.
Yeah, we had two microphones going. That's the problem. Sorry about that. Okay. Okay, so what are we going to talk about tonight? First, I'd like to talk about the significance of lunar ice in terms of the space economy, and also talk about what the importance of ice is. It's actually rocket fuel. Hydrogen is the fuel and oxygen is the oxidizer. Very simple. What is the origin of lunar ice? Well, interestingly enough, the moon is not the only place in the solar system where we suspect a lot of ice occurs, and that also is on the planet Mercury. Actually, there's probably more ice on the planet Mercury than there is on the moon. And I'll explain why we believe that.
I'm gonna try to make the lights better.
Thank you.
Thanks. Yeah.
I never can remember what I need to do.
There we go.
Better?
Yeah.
Okay,
Perfect.
yeah, thank you.
Thank you.
Yeah. I'll explain what PSRs are, permanently shadowed regions, and those are very important because that's where we suspect the ice exists. And in other words, in the base of lunar craters that have not seen sunlight for at least about 3 billion years. We believe that most of that ice was introduced along with another host of volatiles from impacts from volatile-rich impactors such as asteroids and also comets. We'll also end up talking about different extraction strategies, how we might mine lunar ice. And then I'll talk about, and this will just be a selection out of a host of missions that other countries are involved in. The Chang'e missions, I'll briefly talk about that. That's from China. Luna 25, I've already mentioned. And then something called Viper, which is actually going to be a golf cart sized object that will roam around on the moon, and it has will have two mass spectrometers and a drill. We'll actually sample the lunar surface where we suspect ice is and actually make contour maps of it. So being a geologist, I'm excited about that sort of thing. Okay, space resources. Let's put this into a bit of perspective. And we'll show an example from the moon and Mars and the asteroids. In terms of resources on the moon, of course, water ice, which is the subject of this talk, there's a wide range of uncertainty. And that's why we're actually physically going to the moon to sample lunar ice and get an idea of what the resources are. The uncertainty is because so far we've been using remote sensing, and that's only can get you so much in terms of really knowing what the resource is. According to Paul Spudis, who unfortunately passed away a few years ago, depending on what instruments are involved, the best guess at the moment is between 200 million and 1 billion metric tons of ice. That is a lot of ice. And we believe that there's actually more ice on Mercury than that. Helium-3 is interesting because that would be a source of low radiation nuclear energy. It depends on fusion. And so obviously we haven't achieved fusion yet, but helium-3 is something that's been passively accumulating from the solar wind implanted in the lunar regolith or the soil for billions of years. And Harrison Schmitt, the Apollo 17 astronaut, is still actively involved in championing the use of the helium-3 resource. We believe that about 650 million kilograms of helium-3 at very low concentrations, about 10 to 20 parts per billion, is implanted in the lunar surface, but there's a lot of lunar surface. In terms of water, Mars certainly has the resource hands down over the moon. There's a lot of ice, of course, in the northern polar ice cap. The southern polar ice cap is actually mostly frozen carbon dioxide, but most of the subsurface ice in Mars is actually in the permafrost. And you can see that the volume, which is 5 million cubic kilometers, is thought to exist there. Whoops, I went back a little bit. Okay. I'm not going to talk about asteroids, but we certainly do believe there's a huge resource of metals and other objects in the asteroids. And of course, the big unknown is how are we going to mine that material and actually bring it down to Earth. Okay, so let's look at the cislunar space and economic potential. What drives the economy of the space economy in the Earth-Moon system basically is something called delta V, which is the change in the velocity of your spacecraft. It takes energy to change your acceleration. And so from Earth to low Earth orbit is a delta V of 8 kilometers per second. From the low Earth orbit to the moon, you have to add another 6.3 kilometers per second. And that takes a lot of energy. In terms of what the economy is in the Earth-Moon system and low Earth orbit, there's a variety of things that have already been done. And you can see the International Space Station is involved in a lot of these: remote sensing, communications, observations, debris mitigation. There's a lot of debris up there, and also propellant transfer. As we move out, geosynchronous orbit, also communications, solar power, observations, and of course we have satellites that are in geosynchronous orbit. And then as we move out to the moon, we're dealing with different types of economies. I'd like to mention briefly the Lagrangian points. There are 5 in any system. The Lagrangian points are basically areas where the gravitational attraction of 2 different bodies is roughly about the same. So if you put any object in a Lagrangian point, it tends to stay stable and it doesn't take much energy to keep it in that particular point. So in the Earth-Moon system, the Lagrangian 1 point, L1, is just above the moon. L2 is on the lunar backside. L3 is way off on the other side of the sun. And L4 and L5 are actually in the Earth orbit and they're 60 degrees apart. But in terms of the Earth-Moon system, we're certainly interested in L1 and L2. We could serve, locations could serve as fuel depots, communications link, lunar observations, and also repair materials involved in lunar mining. And on the moon itself, of course, the economy would be mining, fuel depot, manufacturing, learning how to live on the moon. The case for going back to the moon is that there's a lot that we still need to learn so that we can actually live in space for extended periods of time. And what we can learn on the moon, we can certainly apply to Mars. And it's only a 3-day trip to the moon, whereas Mars, current technology is, you're talking about 5 or 6 months at least. So the big limiting factor are propellant costs. It takes a lot of energy to get materials from the surface of the Earth up to even low Earth orbit. For example, this bottle of water here, actually, if you wanted to get this bottle of water to the moon at current lifting costs, it's about $70,000 just for something like this. Even though we're bringing that price down with advanced technology. And that's what this graph shows. The higher the blue bar, as you move out from the Earth, the low Earth orbit, geosynchronous orbit, the L1, and then the surface of the moon, the cost goes up. And that's in terms of thousands of dollars per kilogram. So if you want to manufacture rocket fuel, it makes a lot of sense to do it on the moon so that you don't have to actually manufacture it on the Earth and then fly it up to the moon. And that's the whole idea of what lunar ice is all about, is actually manufacturing your own rocket fuel on the moon, because the cost is much less than hauling it all the way up there. Based on $3 million per million, the resource would be about $2.4 billion of revenue, just mining or manufacturing 450 metric tons of lunar propellant per year. So that definitely would save on costs. So what is the origin of lunar ice? Basically, the moon has a very low obliquity. In other words, its tilt to the sun is only about 1.5 degrees. That means that near the poles, there are areas where the sun simply does not shine. And these are areas that are in the interior of deep lunar craters. And so here's an image. You're looking down on the lunar North Pole. This is from Ben Bussey and Paul Spudis. And you can see some areas here that are in shadow. And these areas have been in shadow for at least 3 billion years. And since they're in shadow for such a long period of time, they're very cold. As a matter of fact, some of these, the bases of these craters are only a few degrees above absolute zero. We're talking about 420 or 430 degrees Fahrenheit below zero, very cold. We don't even have the technology yet to put instruments into, mining material into such low temperature environments, but we're working on that. But over the long period of time, at least 2 billion years, and this is something from a paper that Arnold in 1979 wrote, that over that period of time, at least 10 to the 13th kilograms of water have been introduced to the moon from various impacts, from comets and from volatile rich asteroids. Now, certainly not all of that material has been preserved on the moon, because any of that material that from the ejecta that settles back down on the moon during the daylight, that is almost instantly sublimated and evaporated, because on the lunar surface during the day, the temperature is about 250 degrees Fahrenheit, even more than it is here today. So,
Almost there.
Yeah, although it certainly feels
It's a dry heat.
It's a dry, it is definitely a dry heat. Yeah. Yeah. Of course, it plunges down to about 250 below at night as well, over the long lunar night. There was an interesting paper that came out in 1961 by a guy named Kenneth Watson before anybody was thinking about lunar ice. And what Kenneth Watson did, he wrote a paper, I forget what the journal was, but he suggested that based on evaporation rates of various volatiles in low temperature environments, and also knowing that the moon has a very low obliquity, there are virtually no seasons on the moon, he calculated that various compounds and elements, here's mercury, for example, sulfur dioxide, hydrochloric acid, and krypton, would have very low evaporation rates as the temperature went down. So this is the log of the evaporation rate on the x-axis. So high evaporation rate at top, low evaporation rate near the 0 point. And then here's the temperature in Kelvin. And I've put two of these for your convenience here. So as we go further to the right on the x-axis, the temperature is actually getting lower. So here's the freezing point of water. And then this is 120 Kelvin, which is about 238 below Fahrenheit. And you can see the evaporation rate of all these materials, especially water, has greatly declined. So even in 1961, we had some folks thinking that there might even be a lot of ice and other volatiles trapped near the lunar poles where the temperature would be low. And even Kenneth Watson wasn't the first. Harold Clayton Urey, back in the 1930s and 1940s, was talking about significant amounts of ice that might exist in the lunar regolith, but he wasn't thinking about the poles. So how much a permanent shadow do we have near the lunar poles? This is based on photography and altimetry from the Lunar Reconnaissance Orbiter, which is in a polar orbit. It was launched, I believe, in 2008 or 2009. It's still sending back information back to NASA. And there's a considerable large areas of permanently shadowed areas near the poles. So the South Polar region from 60 to 90 south latitude, a little bit over 90,000 square kilometers. There's much more in the lunar polar region of the north, as you can see. So the total, there's a little bit over 260,000 square kilometers of area on the moon that is in permanent shadow. So why are we interested in actually going to the poles? And there's some pluses and minuses in doing that. The pluses are that we've mentioned that there's a large water ice resource. It's an area of small diurnal temperature flux, because if the sun is right there on the horizon and it's not moving, you basically have virtually no difference between day and night. So the temperature is fairly constant. It's fairly stable. Interestingly enough, if you're on the rim of some of these craters that are exposed to sunlight, they're exposed to sunlight all the time. The sun never sets. And so those would be beautiful places to build solar, solar arrays. And that would be great for manufacturing electric power. Also, the proximity to the lunar far side. You wouldn't have to go very far. And that's an area where it's shielded basically from communications from the Earth. So it'd be great for radio telescopes, for example. On the negative side, both poles are relatively depleted in metal content. You'd have to go to other areas of the moon to mine, for example, titanium, like the Sea of Tranquility, or Oceanus Procellarum, which is on, as we see the moon, it's on the left side of the moon. Also, it takes a little bit of extra delta V to get from equatorial orbit to get into a situation where you can land at the poles, although that's relatively insignificant. So I've already talked a little bit about this concept of the percent illumination and taking advantage of that. So this is a map from Ben Bussey and Paul Spudis several years ago. We're looking down at a piece of the moon. We're looking down on the lunar North Pole here. And the color code is such that white is an area of 100% solar illumination, and that's occurring on the rim of these craters. Down all the way to 0, which is black, and these would be in the floor of the craters where there's no illumination whatsoever. So you could build your solar power installations right there on the rims of these craters, harvesting solar energy almost all the time. And you could direct that solar energy into the floor of the crater itself and heat up and evaporate that trapped volatile material. So that would be one way of getting power to actually help with the mining. Let's switch to the South Pole. And what we see here is a map that shows the temperature of the surface of the moon near the South Pole. And again, hot colors are high temperature areas, and the purples and the blues are very low temperature areas, all the way down to about 25 Kelvin. So that's only a few degrees above absolute zero. And of course, as we expect, the floors of some of these craters are areas where the temperature is very low, and therefore the volatiles that are trapped there are just going to stay there because there's not enough heat to liberate them. And at various temperatures, you can see the stability of certain compounds and elements. So sulfur, for example, sodium as we go lower, mercury, we believe there's actually mercury in some of these craters. Water, you can see the stability temperature for water, and ammonia. And there are other materials like methanol that we suspect are in some of these PSRs, or permanently shadowed regions. We already have a good hard data point from a crater called Cabeus. And it's, as you can see, it's a little off the South Pole. There's the South Pole. The Centaur rocket, one of the booster stages, was intentionally impacted into Cabeus crater a few years ago with the idea of creating an ejecta plume, liberating some of these volatiles, and seeing the interaction of the volatiles with ultraviolet light, from which we inferred from the hydroxyl ions and some of the other ions that there indeed is volatiles. There are volatiles in the lunar surface. In particular, at that particular site, we believe that the weight percent of water at Cabeus crater is 5.6% plus or minus about 3, which is actually pretty high because there's a lot of areas where we believe that the weight percent of water is actually less than 1%. And this is a recent image from NASA. And so in blue here, I mentioned Cabeus crater. There's a whole host of craters, Shoemaker and Faustini and others, where we have pretty good evidence that there's lunar ice in these craters, and that's highlighted in the blue color here. There are, however, some factors that have led to an erosion or decrease in the ice. And about 3.5 billion years ago, we believe that the axis of the moon shifted, and I'll go into that a little bit why that happened. When that happened, it actually exposed some of the lunar ice that had been accumulated, and that lunar ice is all gone. So that apparently did not happen to the planet Mercury, and that's why we believe Mercury actually has more ice at its poles. There are always there's always impacts from micrometeorites and other meteorites on the moon that churn up the regolith and expose the volatiles, including the water ice, to the surface, which then are out of the cold traps, and therefore they get liberated. High energy cosmic rays are always impacting the moon. And interestingly enough, even ultraviolet radiation from distant stars is thought to actually contribute to the erosion of some of this material. This image is from Chandrayaan-1, that's from India, and this is from the Moon Mineralogy Mapper, which we also call MQ. And the bluer the color, the more basically hydrogen is trapped in the lunar surface. And this is only the top about 30 centimeters of the lunar surface here. And so as you go toward the moons, you can see that there's a relative enrichment of hydrogen, which is a proxy for ice. Okay, I mentioned that about 3.5 billion years ago, the moon's axis shifted. And the reason why we believe that, and this is a paper from Siegler et al. In 2016, is that there was a lot of magmatic activity starting at about that time. There's heating up of lunar interior from the decay of radioactive elements, which produced magma plumes. And there are a lot that were emplaced in what we call Oceanus Procellarum, which if you look at the moon is sort of on the left side of the moon, and that altered the moon's density. And the result of that was that it actually changed its moment of inertia so that the moon actually shifted at about 1.5 degrees. And what that did was it actually exposed some of the lunar ice that had already been accumulating. And we see this in the offset of the concentrations of ice versus the South Pole. So we're looking at both the North Pole and the South Pole, north on the left and south on the right. And these dots here are evidence of lunar ice from different probes, from the Moon Mineralogy Mapper, a LOA, which is the Lunar Orbiter Laser Altimeter, and a diviner, which basically measures thermal inertia of lunar surface materials. And you can see that the concentration is actually off center. Higher concentration is off axis as well. And that's something that we would not expect if the moon had not shifted its axis. So there's a lot of unknowns. And what is the lunar ice? In what form is it in? What is its concentration? Is it uniform? What is its depth of burial? We just have a lot of questions that still need answering. And some of those questions include what form is it in? Is it disseminated or is it in layered sheets? Probably disseminated, since it's been hit by, churned up and reworked by impacts. What is the depth and thickness? We believe that it's probably shallow, maybe only about 40 to 50 centimeters deep, but we're not quite sure. Is it thicker in certain places? What is its lateral extent? Does its lateral extent conform exactly to lunar topography? That's something that we don't know. We have high resolution maps of lunar topography. This is of the Shackleton crater floor, or part of it. Shackleton is pretty close to the southern pole of the moon. What are the concentrations? We believe that the baseline concentration is about 0.5 weight percent, but we've seen from that impact near Cabeus crater from one of the stages of the Centaur rocket that sent the Lunar Reconnaissance Orbiter up there, that there was a local concentration of nearly 6% weight percent of ice, which is uncharacteristically rich. What's the percentage of origin types? Are these mostly from comets or some from asteroids? And how are we going to determine that? Probably through isotope experiments. And also there are differences in the composition of the lunar soil itself. How does that relate to, or does it relate at all to, different concentrations of lunar ice? Are iron-rich soils, do they have a different affinity for water ice than, say, titanium-rich soils or magnesium-rich soils? We don't know that. But we're going to find out, and there's a host of missions that are going to be sent up there from different countries that are going to enable us to answer perhaps some of these questions. I mentioned the Lunar Reconnaissance Orbiter, Chang'e from China, Chandrayaan-2 from India, the Artemis program from NASA has the Capstone program. Korea will be involved, and also Japan as well. As a matter of fact, there's quite a number of planned missions in the near future, 37 robotic missions. What I'd like to do in the time that I've got is say a little bit about the Luna 25, Viper, which is a NASA mission, and the Chang'e series, which is from China. And so China is about midway through its Chang'e series. It's already since the first time since 1976 actually returned some samples from the moon. It had a lander and a rover. This was in Oceanus Procellarum. Again, as we look at the moon, the big dark area of the moon on the left or west side of the moon. There's a far side sample return that's being planned probably 2024, Chang'e 6, and then Chang'e 7. There will be a survey mission, and then Chang'e 8. Then they'll start technology testing for a moon base. This is sort of a fisheye lens view of Chang'e 5. And again, I mentioned this is the first lunar sample return mission since 1976. And that was Luna 24. And a tiny amount was brought back, 1.7 kilograms. Does anybody know how much the Apollo missions brought back?
Altogether?
Altogether.
800 pounds?
Pretty close, about 865 pounds. Yeah. Yeah. This is a Lunar 25, might be launched maybe next month. The first Luna mission since 1976. They're not targeting the South Pole. They're a little bit off north of the South Pole. Well, actually, anywhere from the South Pole is north. What am I saying? Right. Duh. I'm thinking alt-azimuth instead of that. Anyway, their mission is to study the surface layer. There was the European Space Agency was cooperating with Russia on cameras to help with the landing. And since the invasion of Ukraine, that's sort of been called off. So I guess the Russians are on their own when it comes to their optical equipment. This is where they're going to land. They're going to land in a crater or near a crater called Bogoslavsky. And you can see it's a little bit off from the South Pole. This area here that's shown in blue, because this is basically an altimetry map, is one of the biggest basins in the solar system. It's about 2,500 kilometers across. It's probably the result of an oblique impact from a gigantic asteroid about 4.4 billion years ago. And it created this big area of depression, which is not centered on the South Pole, but pretty close to it. Okay, let's talk about the NASA mission, and that is called VIPER. It stands for Volatiles Investigating Polar Exploration Rover. The idea is to send VIPER up there in late 2024. The vehicle is going to be a SpaceX Falcon rocket. It'll be up there about 100 days, and it will actually move around. It's a rover, about 20 kilometers distance, 3 mass spectrometers. I mentioned 2 before, but actually 3, and a 1-meter drill. And it's about the size of a golf cart with a top speed of 0.72 kilometers per hour. So this thing is going to be very careful and very slow, and it's going to take a while to traverse the lunar terrain. Here's some of the hardware that is going to be on it. The mass spectrometer observing lunar operations, otherwise known as MSOLO, which MSOLO, I guess that's actually being hidden by the little screen sharing thing there. Its mission is to directly detect potential lunar ice and actually make a map of a concentration. It'll have a 5-meter swath. It'll also look at gases near the lunar lander to check for degassing of materials. It'll monitor the local environment, composition changes from lunar day to lunar night. And it's not just water that is going to be detected, but carbon dioxide, carbon monoxide, a whole host of other things, diatomic hydrogen, hydrogen sulfide, and things like that. It will be able to detect sublimating water ice in concentrations as low as 0.5 weight%. And then it's going to be looking at isotopic ratios to try to answer that question: is what is really the origin of the ice? Did it come from mainly asteroids, or did it come from comets? It could have also come from giant molecular clouds, which the Earth is known over its 4.6 or 4.5 billion years history to actually have gone through giant molecular clouds that are in spiral arms. And also there are volatiles trapped in the Earth's magnetic field, and the moon passes through that magnetic field. And so maybe the Earth itself has contribute to some of the concentrations of these volatiles as well. There will be a drill, and it's called Trident, and it will provide samples at 10-centimeter intervals. I won't read the whole thing here, but it costs about $80 million. And that $80 million gets you down to about 1 meter into the lunar surface. It's going to look at a host of things, including sediment density. It's going to produce some cuttings, and maybe the Bureau of Economic Geology might get some, and I'll be glad to look at those. I'll invite you over there. The maximum drill depth is actually only about 40 inches. So it's about a meter, I guess. So this is what a setup would look like. You have a series of solar arrays, which will take advantage of the fact that in these polar areas, the sun will not set, or if it does set, it will only be for a short period of time. We'll actually have habitats and labs. We'll have a series of rovers that will be going across these crater floors to characterize the concentration of the water that's trapped in the soil. There's a landing pad, and then we'll have storage facilities behind a berm to protect the water storage areas from the blast from landing and takeoff. Here's a possible water ice extraction strategy. Again, I mentioned solar energy as being important. It doesn't have to be solar energy. You can use nuclear energy, for example. But basically, you want to heat up and liberate the material. This would be probably a relatively safe way to do it with heliostats. And you collect the material, and it actually has an acronym called IHOP. Hydrogen oxygen production. So I don't know if any potential lawsuits will be involved. So it's an exciting time. We're going back to the moon. We've already sent the Artemis mission, has already sent an unhuman, there, that's politically correct, probe around the moon and back. And so here's a timeline of 2020. So we've already accomplished some of these things out to about the year 2035. And so the NASA Space Launch System is already in operation. The Luna lander, that's Luna 25, if successfully launched, will be next month. A NASA crewed lunar orbit mission will be pretty soon, before you know it. We're looking at maybe 2024. That's next year, to actually get humans in lunar orbit again, just like in Apollo 8. And I have to pause at this point. There's a funny story about Apollo 8. That was Borman, Lovell, and Anders. And that was a daring mission. We decided to really move things out by sending astronauts around the moon and returning them. Not landing, but returning them. And when they splashed down, the Navy chopper pilots were coming out, and they were in radio communication. And one of the chopper pilots said, "Well, is the moon made out of green cheese?" And William Anders said, "No, it's made out of American cheese." But this time it's going to be international cheese. And then we're going to stay on the moon. We'll actually be there and have permanent human habitations. This suggests maybe 2028, maybe even before that. The first habitats with support systems fully operational after the year 2030, and then semi-permanent lunar settlements by 2035. And hopefully by that time, we will have picked up our learnings from all of this and transferred them to living on Mars, because that's really the long-term ultimate goal. So in summary, we've looked at a little bit of what the space economy is in terms of where you are in the Earth-Moon system, how it makes economic sense to make rocket fuel on the moon rather than here on Earth and lifting it up into space. The origin, the permanently shadowed regions, those are the areas in those deep lunar craters that have not seen sunlight for at least 3.5 billion years. And these are what we call cold traps. Again, very low temperatures, only a few degrees above absolute zero. The resources, there may be as much as 1 billion metric tons of lunar ice at both poles. And again, an exciting time. Stay tuned because it's not just the United States, but it's other countries. Truly an international idea to go back to the moon, not just to go to the moon, but actually to live on the moon and have an economy on the moon. And with that, I'm done. I'll be glad to answer questions.
Thank you. I just want to mention for everybody here, some of the presentation got cut off because of display ratio or whatnot up on
Yeah.
the screens. But everything is shot is coming through on YouTube fine.
Okay.
So you can go back and watch and
You've
catch
got some
everything.
questions, Terry.
Okay. Also, if you guys want a copy of this presentation, give it to you. Yeah.
Awesome.
Yeah.
I have a question.
Oh, okay.
Go ahead.
I guess go ahead and then Brian after.
Okay.
Yeah.
Just thinking about so many different missions from so many different countries. Is with the exception of the US and Russia, are people cooperating? What's being done? Is it duplicative or are they looking at different aspects? And so some way it can all be put together at some point?
It's both additive and duplicative. It's all over the map, I guess. A good example of additive or cooperative would be India and NASA. The Chandrayaan probe, for example, that was the probe that India sent up there, but they used the NASA's instrumentation, the Moon Mineralogy Mapper, to bring back information. Also, we partner with the European Space Agency as well. China so far has not shown too much in the way of cooperation with other countries, although they are going to, I think, send or share samples with France. So there's something opening up between France and China, maybe political more than technological. But as far as the US and Russia, it's not a good environment for cooperation for obvious reasons. But there's a lot of cooperation between Japan and the United States, and also Canada and the United States, especially the International Space Station. So, yeah, it's all over the spectrum.
It just seems like there's so many resources, and I just wonder if some of them are being wasted because for political reasons, or China, I can imagine going.
Politicians waste money?
What?
Politicians waste money? I'm shocked.
I'm shocked to hear that.
So it's not ideal, but it's not totally everybody separately.
I think overall it's better than it was back in the glory, if you want to call it that, glory years of the space age, because there was that intense competition between the United States and the Soviet Union at that time.
Thank you.
So, yes, Brian.
If I can sure I heard you correctly, when you said like 80.5 million, was that just for the drill or is that the entire mission?
I think that's just for the drill, I believe. Yeah.
Who makes that drill?
Yeah. No, that actually, yeah, I don't know, but we can do it cheaper at the Bureau, I can tell you.
All missions, we know who made the drill for that.
Yeah.
Black and Decker.
Yeah.
Seriously, they made the motor for that at that
Yeah.
time, and I don't know what that drill cost, but I don't think it was anything like
Yeah.
80 million for a drill.
Now, it's possible that I'm conflating that with the mass spectrometers and some of the other materials. So it's a good question, but there's a guy, Doug Wyatt, who actually works at NASA, who sent me that slide. I can check with Doug on that. But yeah, it ain't cheap.
Well, we really want to
Yeah,
know.
even mass spectrometers are nowhere near that expensive.
Yeah, right. I can use my pocket knife, I guess.
Remember, it's government work, so.
Yeah.
No, I've used them in my undergraduate days in chemistry.
Yeah.
They're fairly common in chemistry labs. They're not expensive items.
Yeah, right. So I don't know, that may include some of the monitoring equipment as
So we got a
well.
question online about the
Yes.
equipment.
Yeah.
this is from Bill Spizzeri, any concern about taking warm electronic or mechanical equipment into the crater, which could warm up the ices? Going to experience losses there, or you were talking about operating, I think, at ambient temperature with that equipment was what we're
Right.
researching.
Yeah, if you're going to liberate that material from, say, pollution, if you want to use that word, from hot items, if you have a collection system there, I suppose you can mitigate any of the volatiles loss. I think just operating in 430 below, Fahrenheit temperatures is going to be a difficult thing to engineer, really. Again, my forte is in engineering, but I know that NASA is spending a lot of time working on that problem.
Yes, Mr. Ambrose, my concern with the question was obviously, oh, I'm sorry.
We got two questions going at the same time.
Bill, we'll get to you in a minute.
Yeah, okay, go ahead. Yeah.
Yeah, so suppose that we're able to use all the lunar ice for rocket fuel, then how many years it can go?
I'm sorry, I didn't hear the question.
How many years? How many years of supply would it last?
Like if they were,
If
making fuel from on
they
the.
were mining all.
Yeah, okay. There's a slide that I didn't include because it doesn't involve the poles. You can actually get hydrogen from almost anywhere on the moon because certain types of soils have an affinity for trapped hydrogen. In particular, soils that are rich in ilmenite, which is FeTiO3. And you could actually mine the lunar, the regolith almost anywhere and get the hydrogen out. And at I think 100 ppm concentration of hydrogen over 1 square kilometer at 1 meter depth. And this is calculations that the late Paul Sputus made. You could get enough hydrogen to launch the equivalent of the space shuttle for 100 years at least. So I think there's no, the limitation on the amount of fuel in the years, I think there's practically no limitation.
Would you still need oxygen?
Yeah.
To ignite the.
No problem with oxygen. The typical lunar rock is about 46% oxygen. Oxygen is present in almost every type of lunar soil and lunar rock. It's follow the hydrogen. That's the key, because that's in much smaller concentrations. Yeah.
Okay, Bill Spizzeri, you want to follow up on your question?
Yeah, follow up, Mr. Ambrose. Okay, my
Hang on
concern.
just a second, I'm trying to get your volume up here.
Okay. I'm usually a loud guy.
Go ahead.
Got it.
Okay, my concern about my question was we're going down there for the water, and obviously we're going to have equipment there to melt and or vaporize the water to collect it, to make rocket fuel, drinking water, whatever. However, to do that, we're going to have to put a lot of equipment down there, which is going to be powered by either solar power, atomic power, I don't know what. And that equipment, I don't think is going to stay cold. It's going to have to be heated up by the electronic power that's running it. And would that be a concern? Have people thought about, well, if we put all this warm equipment down there, we're going to ruin the resource we went there to get. We're going to warm up the water we went there to get. Do they think about that angle at all?
Yeah, I'm sure that's been considered. And I think it won't be exclusively solar power that will be involved. I think nuclear power as well, because then you can have mobile material. I don't know the specifics to answer your question, but yeah, it's going to be a challenge to move around on those crater floors and not disturb that material, because a lot of that lunar ice is in fine grains. It's disseminated and it's probably very shallow. Even an astronaut's boot, if an astronaut wants to walk in those low temperatures, would disturb that material. So I don't have a good answer for you, but I'm sure that NASA has spent a lot of effort thinking about that.
Okay, thank you.
Like a boat in the Gulf of Mexico, like it would be a very local thing. You might have a little bit of loss, but over tens of thousands of square kilometers, that's not much
I
loss.
think that will probably be, handled, that will probably be taken care of, I would think. Yeah. Anybody want to go to the moon?
Sure.
All right.
Yeah, when's tourism start?
Adventurers all.
Yeah, we got 2035 living there. So
Yeah.
good.
Yeah.
That's a tourism.
Yeah, well, the moon is a harsh mistress to, I'm not coining that phrase. Is that Robert Heinlein? Anyway, yeah, there are enormous temperature differences, between an area, during the day, about 250 degrees Fahrenheit, and then those PSRs, about 450 or maybe 430 below Fahrenheit. That's a temperature range of what, more than 650 degrees.
But you mentioned there were some areas that were kind of stable.
Stay on the
So if you're gonna put the
terminators.
habitats in areas that don't have much change, and then you have the remote equipment that goes down into the crater.
Yeah, so you can put a habitat in an area where, the sun is
Kind of setting all the time.
yeah, it's not really
Pretty
changing
low,
its position in the
right.
sky relative to where you are.
Good luck sleeping.
Yeah, also, but you can't live on the surface though, because there's no protection from micrometeorites. So you have to go underground, maybe into collapsed lava tubes, which we've mapped on the
Yeah, you
map.
cannot stay on the surface.
No,
I'm gonna ask you, so I know this.
yeah,
Do you want to survive?
it's a high radiation environment too.
Yes.
Yeah, I mean, the
Let's go to
moon
the
has no
lava.
magnetic field, no atmosphere. Yeah,
Work out the-
right. So, and the similar thing exists on Mars.
We're gonna need a bigger drill.
Do you have a question?
No, that's what I was mentioning.
Okay.
The radiation alone couldn't just stay up on the surface with this.
There is just
amount of
no
sunlight.
way. Yeah, right. I mean, it would be like getting the most intense MRI like twice a day or something like that.
Yeah, 6 months, you're dead.
Yeah.
Yeah, right. So dangerous place, yeah. But we live underground, I think.
Just a comment, if you want a dramatization of some of the questions that we've been asking here, there is a 3-season series on Apple TV for all mankind. Reimagines the space race from the beginning. The Russians got to the moon first, and we were actually spent a lot of episodes with the Russians and the Americans kind of fighting it out low level while they're mining ice in Shackleton crater.
Oh, okay.
And so political and mixes everything together.
What's it
So,
called again?
for all mankind.
Oh,
Okay. Well, humans have never competed for resources, right?
No.
Not at all. Yeah.
So the resources are free, so I hope Elon Musk is not thinking to go there.
Free.
Yeah, because you say the corporation, when people start, oh, we can make money with this, right?
Yeah.
Go to our corporation.
Well, I have an acre on the moon. They sold me a certificate saying I own an
Oh,
acre.
yeah.
on the moon. I do have-
Right. So you have mineral rights?
I don't know what goes along with that. It's only
Yeah.
$20.
What's the temperature arrangement there?
Yeah. Well, currently NASA is totally focused on the water ice, and they're not so much interested in the helium-3.
Okay.
They were a while, but not now. But Japan and China are very serious about mining helium-3. Now, whether that could be economical in the long run, well, first you'd have to get fusion to work, because that's how it's going to happen. You'd have to fuse helium-3. But the benefit, the theoretical benefit of helium-3 is it produces very few neutrons. It's a low radiation form of nuclear energy. It can.
What about its use as a superfluid?
Excuse me?
What about the use of helium-3 as a superfluid?
As well. Right.
Zero friction when things are moving. through
Indeed.
it.
Yeah. Right. It can be used actually as rocket fuel, ion rockets, for example. We have xenon ion rockets have already been sent into space. Smart 1, which was ESA, was a xenon rocket. It didn't move very fast, but it doesn't have to all be liquid propellants.
So at one point you mentioned that it's cheaper to manufacture the rocket fuel there. but you also have to get all that equipment up there.
Oh,
that
yeah.
Isn't going to be free.
Absolutely.
So is there kind of like an estimate of like, what's the payoff of like, I gotta spend all the money up front to get all the stuff there.
There's a lot of
ROI on
Yeah.
getting the cost back.
Right. You know, there have been economic studies. There's a guy named Mike Duke who's retired. He actually, I think he still lives in Central Texas, who's done some studies. And it's a long period of time of upfront costs. And really,
Mostly bringing the cost of launching way down.
right, but you know, an economy, but you know, going back between the moon and the earth, you know, importing materials, I don't know if that economy will ever really be realized. The whole point is the moon is part of a, for lack of a better term, a stepping stone to the eventual to be somewhat dramatic about conquest of the solar system. You know,
Would it also potentially be like a refueling station? So like you don't have to launch all your fuel you need to get to Mars. You make some of it on the moon and pick it up on the way.
Right.
It'll be a Buc-ee's.
Yeah.
Don't give them any ideas.
There's bathrooms outside of Earth.
And see,
How many signs along the way?
and the guys, you know, the folks who support Mars over the moon say, well, forget the moon. You actually have two little asteroids that are in orbit around Mars, Phobos and Deimos. And those may have water ice on them. You know, they're carbonaceous chondrites. And so you actually might mine Phobos and it's right there. It's only just a few thousand miles above the surface of
You know, also like making
Mars.
your return, right? You gotta have return fuel, so.
Yeah,
you
so
pick a
Phobos
refueler.
might be a refueling station. Yeah, and it's so close to Mars. And it's so close to Mars that north and south of the 69th parallel, if you're on Mars, you actually can't see Phobos. It's below your eye. That's how close it is to the surface.
Is there another question?
Anything else? Anything online?
I don't see anything written.
Okay.
Anybody online harboring a question they'd like to ask?
Maybe check the chat, the text chat, and see if they.
Yeah, I've only had Bill's question on chat, so.
Okay. Yeah.
Okay, well,
Okay.
unless anybody has anything else.
Tell us why Mercury has more ice?
Yeah, one reason I